Hey guys, welcome to our second lesson of continuity. This time we're going to be discussing continuity to a certain extent, and we're going to be also learning about the intermediate value theorem. So the definition of continuity, you guys already know it. It has three conditions. Here's condition number one. The point must exist, the limit must exist, and the point and the limit must be the same value. Now we're going to go ahead and apply the definition of continuity to the first example. Now the first example says use the definition, which is right above there, to prove that the function is discontinuous at x equals 2 if a is equal to negative 4. Okay, so if a is negative 4. Okay, so let's rewrite this. We have a piecewise function. Now we have negative 4x plus 7 if x is equal to if x is not equal to 2, and 1 if x is equal to 2. So let's do the most easiest part. Okay, let's go ahead and draw it like this. So here's 1, 2, and it says when x is equal to 2, y is 1, because y is f of x. So, and it's only a point. Okay, alright, so, and for every other point that is not 2, in other words, everywhere else, we have a function negative 4x plus 7, a linear function. So I'm going to go ahead and try to scale this as close, as accurate as I can. So here's 2, 3, 4, 5, 6, 7. And since it's a negative 4x, that means we're going down 4. Here is our y-intercept, because that is our b in our mx plus b equation. 1, 2, 3, 4, 1 to the right, and repeat 1, 2, 3, 4, 1 to the right. So I'm going to say that this is my graph. Very straight, I know. Now I'm going to draw an open dot here, and then continue this graph to the right. Okay, now I know I'm not very good at drawing, okay, but we see that this is the linear function, negative 4x plus 7, and this is the dot 2 comma 1. Is the function continuous? No, not continuous. Which criteria does it fail? Well, the point is defined, so it passes the first criteria, the first condition. The limit does exist because the limit is that y value, which is 1. I'm sorry, negative 1. So it passes the second criteria. It doesn't pass the third criteria because the limit and the point, in other words, f of 2 is equal to 1, the limit as x approaches 1, as x approaches 2 is equal to negative 1, and those two are not the same value, so it fails the third condition. Now we're going to go ahead and use the same definition, except now we're going to go ahead and find the k value that does make the function continuous. So now we're doing a more abstract example here. So use the definition of continuity to find k so that f, the function, will be continuous at x equals 2. So now we got to not make it up. Now we got to derive the k so that the function is continuous. Okay? Well, what does it mean for a function to be continuous? Well, the point must exist, the limit must exist, and the point and the limit must be the same. So in piecewise functions, we're given two pieces. This is considered the left side of the graph. This is considered the right side of the graph. If we can find the limit as x approaches 2 from the left and x approaches 2 from the right, then we can find our missing k value. So what this means is that simply plug in the limit as x approaches 2 from the left of x plus 3, because we're doing the left part, hence the negative sign. Plug in the limit, and we get 2 plus 3, and that's 5. That is the left-hand limit. The limit from the right, notice the plus sign, is kx plus 6, of kx plus 6. Now plug in the 2 into the x, and now we have 2k. Notice that k is still unknown, and that is simply just 2k plus 6, and that is considered your right hand limit. Now this function has to be continuous because we need to find the k that makes it continuous. So what does it mean for a limit to exist? Well, the left hand limit and the right hand limit equal. So I'm going to equalize those two side limits. 2k plus 6 is equal to 5. Solve for k. Very simple. We have -1. And I'm just making sure I know how to subtract. -6 out of 5. -1. 2 over 2. K is equal to a -1/2. So my final answer is x plus 3, -1/2 x plus 6, when x is less than or equal to 2, and when x is greater than, not equal to, greater than only 2. You can graph this function in your calculator, and you should see that the function is continuous. In other words, from the left side you have 1, 2, 3, when x is less than 2, so something like this, crossing at 3. On the right side we have the y-intercept at 6, because of the 6 is b, and it'll do something like this. And it's continuous because the limit exists, the point exists, and they're both the same value. Okay, so I'm going to go ahead and continue this part of the video. I'm sorry, this lesson with a part 2 of this lesson.